So we know that we need to start with the data. We have to know where we are in order to know where we want to go. The second panel is going to be all about action. Once you know where you are, where you really need to target, and then maybe what the distance is between where you are and where you want to be, you know that you need to put certain things in place. And the good thing is that we have a lot of ready-made solutions that are available now to help decarbonize buildings, whether or not you are running a factory, offices, a healthcare building. All of these complex buildings, we know that we're creating emissions by powering these buildings with our standard energy. Luckily, there are a lot of really great, ready-made, cost-effective solutions that you can put in place now. So to talk about how to bring all of that together today, we have a great panel. With us today, we have Ravi Prasher from Bloom Energy, who is the CTO. We have Dan O'Brien from DSD Renewables, SVP Energy Solutions. We have Matt Plant from Voltus, president and co-founder, and Mark Reinbold from JCI joining us as VP Global Sustainable Infrastructure. So thank you all. Looking forward to the discussion. To set the context, I think it's fair to say that decarbonizing your buildings and putting together that energy strategy is complicated. Raise your hand if cost is a really important driver for you. Keep it up if resiliency and reliability is one of your key concerns. We have a lot of people that are not concerned. They're like, I've got this figured out. What about scale and physical imprint? Can these solutions fit inside your space, inside your physical imprint? Yep, okay, that's a concern. And then what about future changes? Here we are, it's 2024. What is the world going to look like in 2029? Is hydrogen going to be cost effective? Do I need to plan for that now? What about greening of the grid? What about the huge increase in electricity use because now I'm turning all of my vehicles to EVs? We know that right now isn't what our future is going to look like, yet we have to take steps now. So to tackle these really complex problems, we have a great set of questions, and we're going to kick it off with Dan. So solar, talking about on-site solar. Solar is one of the most iconic, arguably the one of the most iconic. If you look at a little figure of green energy, it's always a solar panel. And yet, when you drive around a city or anywhere, we don't see as many of those as we want. So can you talk to us about customer trends? What are some things that customers or organizations that are making these decisions should be doing more of to really get the benefit of on-site solar?
Sure, no, that's a great question. I think that there's a few different layers to unpack there. Yeah, the first is that previously 20 years ago, 30 years ago, there were two mechanisms to deploy solar on site. It's cash purchase, and in today's market with the cost of capital, that gets very difficult. Expertise is also, challenging. And then the other aspect was going with a financed route, which is a straightforward power purchase agreement or an equipment lease. And now the market is starting to shift after the space has started really listening to customers' challenges. Some need RECs from that system. They need to own them outright. But RECs and sustainability benefits are a critical piece of making, the ROI work. However, now there's greater value with potentially keeping those RECs and retiring them, yourself. The other aspect is understanding what you're going to do with, your facilities, with your assets, and how you're going to look to potentially handle your load. Whether it be, you have a massive increase in load coming from, fleet electrification, and you have to understand what that impact is going to do to your facility, and then how you're going to have to size your on-site renewable system to, handle that. And then the other aspect is knowing that people and companies are working with potentially challenging lease terms if they don't own their asset outright. So then it's working with your landlord to figure out, or structure a business deal that can work for both parties. I think as the space has shifted over the past 2-3 years, there is such a focus on ensuring that projects not only provide OpEx savings, they minimize CapEx outlay, but also incorporate those sustainability benefits. That is something that was not a strong aspect of the market, again, 5 years ago.
Thank you. Ravi, could you tell us a little bit, set the stage on fuel cells and the solutions that Bloom is taking to market, and what really key kind of unique problems are customers looking to solve with your systems?
Yes. Let me do a quick poll. How many of you know about fuel cell? Oh, that's quite a bit. That's very impressive. Well, so look, first of all, let me give it briefly how the fuel cell works, so the context. So typically, if you look at a gas engine, turbine, or reciprocating engine, we take a chemical fuel, then we burn it to create heat, then we convert that heat to mechanical energy, and then mechanical energy goes into running a generator to give you electricity. So you have 4 steps. Leads to a lot of complexity, includes emissions and inefficiencies in the system. Fuel cell does direct conversion, so takes the chemical energy, converts it directly to electricity. So one-step process, and that's the beauty of the technology, because of which it has a lot of different traits, which is very relevant today. One is that it's very fuel flexible, so you can go all the way from 100% natural gas to 100% hydrogen on the same technology. So that flexibility is amazing for future-proofing, as you asked this question, that how many of you are worried about future-proofing of the technology? And that's one. Second is that it's very energy dense. Okay, I mean solar, if we compare solar, and if you want to get 100% of electricity from solar, for example, then you have to put a battery, then a lot of solar panels. Compared to that, a fuel cell will consume less than 100 times less space, roughly, more than 100 times less space compared to solar plus battery, right? So that's where, in terms of on-site generation, when you want a lot of reliability, a lot of resiliency in the system, you have challenges from the grid, fuel cell becomes a very, very lucrative option. And that's why a lot of our customers, they use our fuel cell as the primary source of power. And those are critical facilities like hospitals, data centers, where reliability is of paramount importance. And we have deployed more than 1 gigawatt worth of fuel cell all over the world, a lot of them in the United States, and powering many data centers in the country and critical facilities like cell phone towers and whatnot, right? So in the terms of the biggest value proposition that we have been able to sell is resiliency, reliability. Another one which is becoming more and more important is time to power. In the previous panel, we heard about AI data centers are going to be energy guzzlers. I mean, a typical ChatGPT search consumes roughly 6 to 10 times more energy than one Google search. That's the number. So it is going to consume a lot of electricity. But the challenge is that today, to get permitting to get connected to the grid, even though you may have a lot of solar available somewhere, it's roughly 3 years when you will get final connection to the grid. So that's another major challenge in the commercial sector, that how do I get power immediately? And so another reason that we have been very successful and there's a lot of traction is because we can deploy the fuel cell within 6 months. So time to power is another very critical piece where fuel cell plays a very big role. And that's why we're getting a lot of interest. So I would say 3 things: resiliency, reliability, and time to power are the 3 things which are driving the business.
Okay, great. Thanks for that summary. Matt, tell us a bit about what are organizations probably not taking advantage of with demand response, with leveraging their building as an asset in the grid. Tell us what your customers are coming to you, and then maybe why do they not want to work with you? Because it seems to me like that makes so much sense.
Me too.
Okay.
So when hands go up to say that cost is important to me, my eyes light up, because I think it was John Doerr who said the most profitable outcome is the most probable outcome. And so we've created this business about paying customers to reduce their electricity consumption. And so what we want to do is we want to take all of your facilities and turn them into virtual power plants that are compensated and paid to provide a service to the grid. And so it actually happened this morning at about 7 o'clock this morning. The electric grid, SPP, which is Oklahoma and Kansas, dispatched our virtual power plant there. and for about 12 minutes, customers reduce their electricity consumption for the grid or use their own on-site generation. And that allows SPP to run their grid on as much renewables as possible, which is the only statistic that I care about. The only statistic in this entire space that I care about is what percentage of the grid is running on renewables. And so our job is to make that as high as possible. And you all need to be part of the solution. And so we're all doing great work. We're all decarbonizing our buildings and our facilities and moving to electrification. But unless we actually increase the percentage of the electric grid that is run by renewables, we're idling. And so by creating these virtual power plants and providing grid operators with a large asset that they can call upon that is dispatchable, that's what's actually allowing them to move to renewables, which are, as it turns out, intermittent. And so it's working. California has had hours in which it ran its grid 100% on renewables. And I don't want any other grid in the world to model themselves after California. But that's one statistic that's hopeful. SPP, which is in these states that we typically liken to fuel-heavy states, coal-heavy states, Oklahoma, Kansas, Nebraska. In June of this past summer, it ran its grid on 92% wind. 92% wind for an entire month. That has never been done before. But it's because they dispatch virtual power plants about 45 times across the month. And so the big difference is that if you talked about participating in demand response programs 10 years ago or even 5 years ago, you were talking about a once a summer occasion when we would ask you to shut down when the grid simply didn't have enough power. But we have a very different problem today than we did. It's not really peak demand that's the problem. It's sudden changes in supply on the electric grid. One statistic is that Texas has the most reliable electric grid in the country. Sorry, it's the least reliable electric grid in the country, Texas. Despite the fact that it has the largest reserve margin, meaning the difference between total demand and total supply is higher in Texas than anywhere else. And yet they have the least reliable grid. It doesn't make sense, except when you think that the grid fails when one thing happens. If it's cold and it's not windy, every asset in Texas is the same. It's either natural gas that doesn't like the cold or it's wind. So when you have no wind and you have cold, the fact that you have 120 gigawatts of power supply in Texas to supply 80 gigawatts of demand, that's a 50% reserve margin, but it doesn't actually help because all assets fail at the same time. So what Texas is doing is they're paying companies to be part of the problem so that they no longer have those resiliency challenges. And so it's hard for me to find a reason why customers can't do something because they're no longer being asked to shut down.
Right, which is a key difference from a couple of years ago or a decade ago, potentially.
And so sometimes it's 12 minutes at a time is what allows us to run a grid on 92% wind, and everybody can do 12 minutes at a time.
12 minutes. I like it. That's your new slogan. Anybody could do 12 minutes. So thank you, Matt. Take a look. I flipped the slide because the key takeaway here is all of these solutions need to come together. It is not a one-size-fits-all. It's not a one-solution problem. So as you look at that, think about where am I playing? Maybe where have I not thought about? And those are the experts that you might want to go talk to when we have our further breakout sessions. So now we're going to go inside the building. Mark, we've talked a lot about generation. We've talked about using your building generally as an asset. Why should people do efficiency? It's not very sexy.
It isn't.
But it provides a really important solution, A, to decrease the total energy demand, which we know over the next 5, 10 years, AI, et cetera, is going to skyrocket. And the other thing is it can solve scope 1, right, inside the building, which could be those hard to abate or hard to buy electricity solutions. So talk to us about why we should still be investing inside our buildings.
Well, thanks, LG. And obviously I was kidding. I mean, we are sort of at Johnson Controls, we're a little bit of building nerds that love efficiency. So I think we actually think that's pretty sexy business. I just want to tell just a quick story about a facility, and I want to see if you all can relate to this same thing in your portfolios of buildings. So manufacturing facility, been around for a while, say it's almost 60 years old. Very, very critical need to have absolute resiliency and reliability. Our revenue depending on it. Some deferred maintenance. Anybody have deferred maintenance in facilities you're trying to work through? Also, energy efficiency projects that you've looked at but haven't gotten approved through the system, gotten approved capital for, had the team on site to go get it done, had the expertise. I'm talking things basic like controls, lighting, HVAC optimization, okay? Does any of that sound familiar? Because now I have to turn the mirror and talk about Johnson Controls, because that was my facility in the Johnson Controls portfolio. One of our manufacturing plants where we had ignored some of the deferred maintenance. We had energy efficiency work that we didn't get done. And the reason that it didn't get done is, I think one that's going to sound very familiar to you, is we had a capital allocation process that just didn't allow for us to make the decisions to go invest in the most basic things in energy efficiency when we were focused on revenue generation. And until we flipped that model, we couldn't get past that. So things that had 1, 2, 3-year payback had been ignored. Okay, we had a chiller, which we make, and we got a picture of these somewhere, that was in that building from 1971. Now, some of you might say, oh my gosh, I can't believe that. But we're pretty proud of the fact that we kept that thing running that long, right? Like, it's pretty good for our service business. But my point with this is that this is a all too familiar story, is organizations that are not taking the basic actions to go do energy efficiency work inside facilities because you don't either have the approval process set up to do it or the capital allocation process is backward. We are experiencing this, sitting across from our customers and leadership teams that are highly committed to all of the technologies, all of the decarbonization efforts that we're all talking about and we believe in. And that leap has not been made. So when LG, asks about, is the energy efficiency business sexy? I think it is. And I think it's one that we can act on now, because we've got to make buildings more efficient and we've got to use less before we can deploy all the awesome strategies that all my fellow panelists have talked about. Before we can put renewables, size them appropriately. Before we can put fuel cells in place. Before we turn the building into a virtual power plant, we got to do the basics. And that's the taking action now. The good news is that all of those basics have great paybacks. And most of that has very, 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 very attractive financial profile. We just got to couple it with the right delivery model, the right financing model. And some of that is what we're going to talk about in the future panels.
Okay, thanks, Mark. Hey, Marty, just as a brief pause, did we get any questions from the audience no? Okay, well, we're going to keep rolling. Dan, so we want to bring this all together. I want everyone here to leave with an idea of how all of these solutions are complementary and how they can fit together, how you should be thinking about each one. With respect to solar, can you tell us a little bit, both you've been in the industry a long time, you're an industry expert, both your perspective on how solar fits with a number of these other solutions, and tell us a customer story that really drives that point home.
Sure. Now, I think that, Mark said it very, very well, that you have to look at all the various aspects that are going into projects at your facility. I think previously, customers have been reluctant to share what those other projects are. And it has caused projects to operate in silos, and they don't always understand the impacts of each project across the board. And now we've seen more and more companies take more of an integrated project, development stance or perspective, where they bring their different partners in, they discuss the projects, everything is clearly out in the open. It was, just stated earlier that you can't have enough solar on site for, certain facilities to actually handle full load or even get close to 100% load. But that's where there's a balance where you need to basically bring everyone in and say, hey, this is what our end goal is. This is what we're trying to do for this facility. This is the plan. This is the roadmap. And that way you can align each project to actually work as a larger piece of that puzzle, as opposed to the puzzle piece is not always perfectly fitting. So I think we've seen that trend starting to occur over the past several years, and that's becoming a much larger level of importance to companies, because now there's so much tech out there, so much data, and so much drive to try to decarbonize assets as much as possible that you just can't do it bit by bit anymore. You have to, again, create the roadmap and then start marching down that road.
Do you have a customer story?
I do. I can't say the name out loud, but
That's okay.
We've worked with several large corporates to help them deploy at scale across the United States on different types of retail buildings. And we have also worked with them on their distribution centers. So we have worked with various groups, some that are not here, to change over their internal equipment to electrified equipment, and had to balance out what that load profile was going to be with the on-site solar to assume for the increased impact. We have worked with them to also find ways to fund infrastructure development upfront. If someone needs a new roof, if they need their existing electrical infrastructure replaced or upgraded, we can find a way to put cash up front. And that has allowed groups to understand that they might not have the capital in that moment, but there's a way to finance it out, which allows them to potentially own those assets at a certain point in time, and it doesn't hit their balance sheets, but it starts driving OpEx savings. It does have that CapEx outlay. They get sustainability benefits, and they get different ancillary, financial benefits as well with it.
Excellent, thank you. Ravi, how do you think all these solutions fit together?
So, let's first of all look at a very macroscopic view, and then I'll come to how fuel cell fits with everything else. So today, our energy infrastructure runs on two things, electrons and molecules. And that has provided amazing resiliency in the system and a lot of reliability as well. So that's what I would say, that we strongly believe in the future, the energy mix will still have combination of electrons and molecules. That molecule today is natural gas. In the future, it will be hydrogen, right? So that's how we look at a very high level, right? Because that provides amazing amount of resiliency in the system and reliability. Now coming back to fuel cell, again, I would say, as my colleagues are saying, it's not going to be one solution fits all. You have to optimize, you asked the question, right? Cost matters, reliability matters, resiliency matters. These are very complex problems, and expecting that one particular solution will solve all of these problems is completely unrealistic. Just to give an example for us, for example, we have a customer where there's fuel cell, there's battery, there's solar. It's a microgrid. Combination of multiple technologies coming together so that we can optimize it for the customer. They want it to be completely off-grid. Okay, they don't trust the grid, so they want it to be completely off-grid, but the reliability is hugely important for them. They want to be as green as possible, right? So that's where it's a great example where you're fitting all this technology, optimizing for cost, optimizing for resiliency, and so on and so forth. Another thing what I would say is a great example is that I raised the issue of time to power. We just had a major deal signed last year in Santa Clara. Santa Clara is struggling for providing power to data center customers. They can't get power, and AI or or any other data center people, they lose a lot of revenue because if it takes 3 years to get power, so again, and they cannot put solar there. I mean, there's just no space. So, and battery also battery means again, you want to connect to the grid to take a lot of power. So all those options were out. So then they came to us and they said, what can you do? And so of course, fuel cell makes a lot of sense because right now they have natural gas available, and then the same fuel cell can transition to hydrogen when it becomes available. And another thing is that typically, if you look at historically in the country, natural gas pipelines have been much more reliable than the grid has been. So that's another major factor for a customer like data center. So these are the areas where we are seeing a lot of traction. And finally, again, I can't leave without saying, as I mentioned about AI. I mean, AI is just an energy problem. There was a Wall Street Journal article 2 days back. It's a massive energy problem, which is knocking on the door. And again, a well thought out strategy is going to be very, very important to enable the AI revolution. Those are my thoughts.
Thank you. Matt, how do organizations become excellent at managing their energy?
They probably hire the right people to begin with. So it probably starts with hiring people who are passionate. So that's probably step one. And then I think they set goals and they use competition. And so it's really important for my company to understand what our customers' energy goals are, and we oftentimes help them set those goals. We have sometimes helped them change those goals because we told them that they had the wrong goals to begin with. And so understanding what those goals are so that we're all moving in the same direction, you get there a lot faster, is a big part of it. And then competition. So everyone likes a little competition. Do you remember O-Power? So O-Power used to send you a little piece of paper that told you what your energy consumption was compared to your neighbors. And it turns out that little piece of insight drove about 3 or 4% energy reduction. I think Robert Cialdini was the economist who came up with some of these strategies that they used. But we do the same thing.
Okay.
So if you're commercial real estate, we help you understand the best practices of commercial real estate and how much money commercial real estate is making from demand response programs, what percentage of their peak demand they enroll, how many programs they participate in, what their kWh per square foot is, all these sorts of things. And so we benchmark those across industries, and it really pushes people to be best in class. I don't want to do worse than my neighbor, and so I'm going to do more.
Interesting, thank you. Sure, before we turn to Mark, we have a question.
It seems like there's a lot of innovative and clean technology that can be deployed. Who should be responsible for paying for the delivery of that power?
Okay, I'm going to repeat it. It seems like there's a lot of clean technology to be deployed. Who should be responsible for paying for the delivery of that power? On the grid? Is that the question? Okay. That's a little bit of a divergence. Let me finish out this thought and we'll come back to that one. So everyone think about if you have an answer to it. And if you don't have an answer to it, that's a great question. Bring it to our panel. Let's have a small group discussion. So I think before we talk about, unless you have an answer to that.
I think we're going to talk about the same thing. So
Okay, awesome.
I think it's a great question, by the way. And I think it comes really down to how do you deliver these things, right? I mean, these are, let's just throw it out there. I mean, we're talking about very complex technologies, right? We're all getting pretty comfortable with solar. Fuel cells are amazing technology and very, very reliable, but you have to put that project together and engineer it correctly. I mean, we're going through one of those projects with our partners at Bloom right now. Same thing is true, with bringing virtual power plant to market. And I think the thing that we all have to consider is can you make all of those choices internally? Can you make all those choices one by one, or do you have to look at that and say, what's the outcome that I'm trying to drive here? What's the outcome that I need to deliver? And is there a partner that can bring that all together, deliver that outcome, and also take risk-sharing responsibility? And we believe, that you're not going to be able to do this on your own, and you have to have partners. And I'm not saying that to building owners. I'm even saying that to folks like Johnson Controls, who have been 140 years in this business. We had to bring together an unbelievable partner ecosystem to be able to deliver net zero buildings. So if you couple a great partner ecosystem with a delivery model that allows us to transfer risk and actually take performance risk on the outcome of delivering net zero, then I think this becomes a lot easier. And then you couple that with a financing model that makes it more affordable. So when you get all of those pieces together, all of a sudden I think you got the right recipe. That the question that came from the audience was, who pays for that power? Well, the real question, is who pays for the outcome of taking you all the way to net zero? How much of that can be paid for out of the efficiencies that you gain? How much can be paid for out of renewable energy? How much, does it really drive an effective payback? It's very, very hard to calculate on disparate systems that you have to deploy all together. And I'll just wrap on this. Think about what it takes to deliver a virtual power plant. And this is amazing technology, but think about what all has to happen inside the building and all of the systems that have to come together. You're talking about EV charging. You're talking about the demand inside of a building. So heating, cooling loads, plug loads. You're talking about what supply choices you make if you've deployed a microgrid on site. Those choices can get super overwhelming. And we see this happen all the time. And that's why we're flipping that model to tell me what you want to achieve and let us help put the team together to go make it possible.
Excellent, thank you. We still have a little bit more time, so I would love to get an audience question. What are some of your hairiest challenges that you're dealing with? Take a minute to think about that you could throw at our panelists. Oh, put them in the app.
Have any of the esteemed panelists, whoever used esteemed, that was nice. Have any of the esteemed panelists had success integrating the cost of carbon into their value proposition and business case?
Great question. So have we worked with any projects? Has anyone worked with any projects that have successfully integrated cost of carbon into the business case?
I could take that.
Excellent.
So we've worked on several projects in which the construction of the solar project was impactful from a carbon perspective. Solar canopies utilizing steel, glass, concrete or an asphalt have a carbon footprint. And we were asked to do the calculation on the specific impact of the construction, from logistics to actual material to actual, labor hours and trucks coming in and out of it. And we were able to calculate that out, and we were able to then go and get those carbon credits that would account for that total footprint and then send them to the customer to retire them. That was embedded in their finance deal, and that was a value piece that they really needed to make that project work from a sustainability perspective. So at the end of the day, though, the tricky part with that is making sure everyone was on the same page with actually the calculus on what the true carbon impact was.
Yeah, my answer, the simple answer is of course. And there's a carbon calculation into every time we work with a customer. And right now it's valued at about $50 per megawatt hour. But the value of taking any load off the grid just from a carbon perspective is $50 a megawatt hour about. So that's a value stream that we were not able to create even 2 years ago, but now we are getting paid specifically for the carbon reduction associated with it.
And who's paying you for the carbon reduction?
So we have a partnership with Meta, and Meta pays us on top of what we would normally be able to generate from energy markets. Meta pays us to reduce consumption from the grid during the dirtiest hours of the grid, which is a first of its kind program. And so Matt, if you want to add on to what Meta is doing with us, you can find me later. Yeah.
You want to weigh in and then?
Well, I mean, a couple things. I mean, I would definitely talk to our friends at Microsoft. They have an absolutely, world-class way of valuing carbon. But I talked a little bit about our own project inside Johnson Controls. And I talked about the broken capital allocation process that led our organization not to do all the things that it needed to do. And probably some of you are facing that as well. Not until you add an imputed cost of carbon does that decision-making change. And that is a super critical thing that all of us could take away, is if you really want to move the needle internally and you want to get things done, and you need a way to revalue projects and how you look at what you procure and what you buy as an organization, and having an imputed cost of carbon is absolutely critical.
I can imagine that most people are thinking, yeah, but how do you get your CFO to agree to that?
Well,
Comments?
That's a great. Anybody want to take that one? I'll take it then. I mean, for us,
Teeing up the finance panel.
Seeing that CFO's decision-making process didn't align in our case with the commitments that we made to our shareholders and our stakeholders and our sustainability report. Frankly, it just didn't line up. So we had to get our own behavior right in line with what we said we were going to go do. And that really started at that CFO level, saying we're going to evaluate how we do projects differently. And we find that, as we're working with customer organizations, the difference between organizations that are moving and getting things done and those that aren't, that's one of them, is lack of having any sort of internal cost of carbon. Second, I think the panel hit on very, very well, which is, do you have the right plan? Do you have the right partners?
Can I add to this? Actually, let's be honest, there's a very healthy, mostly healthy debate happening between what the business wants in terms of monetary value, and then how do you still satisfy the ESG goals. There's a lot of debate happening in every company, right? So I at least in our experience, two things, all right? One is, for our technology, they look at the marginal emission rate and figure out that, okay, this is much, much better because today we are running 100% natural gas. But the other question, as CTO of the company, I always get asked, how future-proof your technology is. We understand that hydrogen is very expensive today, but the whole federal government of the United States has put all these policies in place with the hopes that hydrogen will become very, very cheap. So the question for them is now, okay, if it becomes cheap in 5 years, can I still use the same technology or not, right? But today, if you go and say to any company that, okay, put price carbon, and you will get a lot of pushback from the business side of the house, right? But they still want to know whether it's future-proof or not.
But you're saying they will value whether or not this solution that you're putting in place now is still going to be relevant in
Yes, that
10
I would
years.
say I have personal experience directly dealing with some major customers, and I had to convince the CTO of a very big company that this technology is ready for hydrogen, and then the CTO of that company convinced his ESG counterpart that yes, this is the right thing. At the same time, today we need this because otherwise we cannot have our data centers running. So there's a lot of dialogue happening.
LG, I also think that model inputs are very critical when trying to calculate out your IRR and your net present value. That if you have the wrong model inputs in there, you're not factoring the right energy cost increase. You're not factoring in the correct demand charges. That the model could be broken. So you have to make sure you're using data to really drive the inputs that go into that financial model to justify that decision. And that way you can look at it from a true, actual reality perspective. We often find times that a lot of companies are outdated in how they're actually modeling out energy costs and predictive energy costs and demand charges. Some don't even know what demand charges are, and they're sophisticated companies, or they might only know it tangentially. So it's making sure that the inputs in the model are accurate to help you drive the value return that you're going to get, then that makes a case in itself.
That's a more polite way of saying what I was going to say, which is if your CFO says no, you're doing it wrong. Like between every company's carbon reduction goals plus every utility's energy rebates, we have more tailwinds in this industry than we've ever had. So if your CFO is saying no, you're doing it wrong.
If your CFO is saying no, come talk to Matt.
Yes.
Awesome. Do you guys have another one?
So there seems to be a theme of how do you convince others to decarbonize? So whether it be if you're in a lease situation, if it's your value chain, supply chain, how do you convince others to invest in renewable energy or energy efficiency in their sites?
Take them to Texas when there's a blizzard. I said, take them to Texas when there's a blizzard. Just the effects of climate change, I think, are so out in the open at this point that it's no longer a matter of, is this actually, true, right? That for skeptics out there, it's you just look at whether events have occurred over the past 2 years, and that should be, a massive driver in itself.
I don't know. I mean, somebody mentioned it in the previous panel that the workforce is also, they want it. So you can't deny. So that's a major motivation for everybody to keep thinking about it because, I can tell you, I also teach at UC Berkeley, and every student and a postdoc, if they are trying to do anything in energy, that's the only reason they want to do their PhD in energy because they're motivated by climate change. Okay, they want to change the world. So I think the question is not if, it's a question of when. Energy transition is finally happening. There's going to be a little bumpy ride, but it's going to happen. Maybe it will take 5 or 10 years, nobody can predict. But we are on the way to energy transition.
I think we all know we want to do it. We need to do it. It's just a matter of putting the right business case around it that takes all factors into consideration and that you're not making decisions about particular technologies or particular decisions in a vacuum. And when you bring everything together, you start to look at things on a total cost of ownership over the lifetime of owning your built assets. All of a sudden you make very, very different decisions. So one quick example of this, we're working and we are partnering with one of the largest automakers in North America. And they're on their energy transition, moving to EV manufacturing and EV battery manufacturing. We started working with that auto manufacturer. Their only focus was the first cost of the plant, first cost. And they were driving down road that had no energy efficiency type decisions being made in that. So to give you an example of that, can you imagine your house without a thermostat? Now picture 7 million square feet of manufacturing facility in a pressurized building without a thermostat. And that's effectively where they were because the cost of that building automation system was too expensive out of the gate. One decision in a vacuum. When we showed them, though, the total cost of ownership and the total impact that would have on their emissions, and then started to put everything in a net present value and sort of move that from a first cost decision, first cost of build to here's what your overall lifetime cost was. That decision was completely reversed. Not only was that reversed, but then they deployed digital. Then they deployed AI on top of digital. Then they deployed some of the most efficient technologies in the marketplace. And this is the difference between, looking at things in that silo and then looking at things on a total cost of ownership and having somebody there that can put that entire business case together and be willing to take risk on it with you.
Excellent. Thanks, Mark. Well, I think that takes us to a wrap. Thank you so much, panelists, for that robust discussion. And the key takeaway is all of these things are complementary. They fit together. We have to do them all, and they make sense now.